Okay, so I'm going to give you a few steps on what I think are your most important things that your thought processes should be as you go through your factoring. All right, so factoring a polynomial. Step number 1, you should always be asking yourself, can I factor out a GCF? So can you factor out any common factor? It should always be your first question you ask yourself. Because if you can, it'll make your life a lot easier, it'll make your numbers smaller, it'll make your variables have smaller exponents. If you can't factor out a GCF, then skip that step. Okay, so first thing I should always ask myself, can I factor out a GCF? Remember, if your leading coefficient is a negative, because some of you guys got points off on that quiz, if your leading coefficient is a negative, you should always factor out a negative. Even if it's just -1, factor out a negative if that leading coefficient is a negative. All right, step 2. If the binomial or if the polynomial is a binomial, so if we end up with only 2 terms, so if the polynomial is a binomial, then you're going to check to see if it is the difference of squares the difference of cubes or the sum of cubes. So if we are left with a binomial, I want to check to see if it's any of those 3. Remember, a difference of squares, if I had x squared minus y squared, that's equal to x plus y, x minus y. We had this in our notes from yesterday. If it was a difference of cubes, then it would be x minus y times x squared plus xy plus y squared. If it was a sum of cubes, x to the third plus y to the third would equal, show my equals there, x plus y times x squared minus xy plus y squared. If it's any of those 3, then you have to go right to your pattern. Okay? If it's not a binomial, and it happens to be a trinomial, so if the polynomial is a trinomial, you can check to see if it's a perfect square trinomial. And the only time we really care about that is if my numbers are huge. Then I would check to see if it's a perfect square trinomial. If you don't remember to check that it's a perfect square trinomial, no loss, because then we can just factor as usual. Okay, so if it's not a perfect square trinomial, or you don't remember to check that it's a perfect square trinomial, just factor as usual. So do your leading coefficient times your last term, find factors of that product that add up to the middle term, make your fractions, and then factor it.
Just a question.
Yep.
Would you do an example for perfect square trinomials or something like that?
Sure.
I don't know what those are.
Well, they're the ones that just end up with, if you end up with like x plus 4 and x plus 4 as your factors, then you would turn that into x plus 4 squared. That's it. And I personally would just factor it like I normally would factor and end up getting there instead of looking to see if it's perfect square trinomial. All right. If the polynomial has more than 3 terms, so binomial, we're checking one of these 3. Trinomial will factor as usual. We'll use that rainbow method. Again, that is not an official term. That's my own term. To factor as usual, if the polynomial has more than 3 terms, so if it has 4 terms, maybe might even have 5 terms, it's got more than 3, you're going to try factoring by grouping. Okay, and you can group the first 2 together and the last 2 together and see if that works. If that doesn't work, then maybe try grouping 3 terms together and leaving 1 behind. Nevin?
Is this 4 steps or 2 steps?
Well, this is all step 2. This is the whole factoring process. The step 3 would be to check the factored form by multiplying. So remember, you should always then get to be able to check it to make sure it gets back to the original. So step 2 is multiple parts. So step 2, you're making the decision, do I have a binomial, do I have a trinomial, or do I have something larger than that, and then what process should I go from there? Okay. All right, so what I would like to do is do a quick few practice problems with you, so you can either continue them onto your notes if you want, or if you want to grab a whiteboard, sleeve, whatever you want to do for your practice space to try some of these problems out. Again, we're not learning a new method because we've learned all of this. It's just kind of making those decisions on where we go. We're going to do a few practice problems together as a group, and then I'm going to give you the homework worksheet for you to continue for the remainder of class. All right, so the first problem is up, so whenever you're ready, jot it down. So I have 9p plus 45, and I'm told to factor it. So the first thing I should be thinking in my head, is there a GCF that I can factor out? Yes, what is it? 9, good. So if I factor out a 9, I'm left with p plus 5. So now, ignoring the 9 and focusing on what's inside my parenthesis, I am left with a binomial. Is that binomial a difference of squares, a sum of cubes, or a difference of cubes? No, it's not. It's a linear binomial. So because it's neither of those, I can't factor this any further, so that is your final answer. No, because it's just going to say factor completely. So you just need to know, am I done or am I not done? Okay. All right. Next one, 8m squared p plus 4mp. So the first question we should always ask ourselves, is there a GCF that I can factor out? Carrie's saying we can take out a 4 and an m and a p. So taking out 4mp would leave us with what?
M plus 1.
Well, 2m plus 1. Good. My remaining factor inside, is it any of my special binomials? Nope. So I can't do anything else to it, so I am done. Nevin.
So you said we have to memorize these, right?
Yes. Yeah. These, I mean, the difference of, yes. Memorize them. All right. So those are pretty easy. And so the beauty of this section is you got some easy blended in with some hard as you go. All right, so next one we have 5x times a plus b minus y times a plus b. Good. So the first thing we should always ask ourselves, is there a GCF that I can factor out? This first term has an a plus b. This second term has an a plus b. So if we factor out the a plus b, what is left over?
5x minus y.
Good. 5x minus y.
And that's our final.
Is this a difference of squares? Nope. Is it a sum or difference of cubes? Nope. Same thing over here. Is this a difference of squares? No. Is this a sum or difference of cubes? No. I am done.
Nothing can be simplified.
Nothing can be simplified. I can't factor out any GCFs here. I can't factor out any GCFs here. All right. So here we've got some binomials. So 64m squared minus 9n squared. So now I've got a binomial. First thing I should ask myself, is there a GCF that I can factor out? What?
No.
No, there's nothing that divides both into 64 and 9, right?
3 might, but no.
No, nothing does. So that is a difference of squares. So what does that factor to? I'm going to have a plus, I'm going to have a minus. So the square root of 64m squared is 8m. It's going to be my first term. What's going to be my last term? 3n. Good. When I get to this, is this a difference of squares or a sum of cubes or difference of cubes? Nope. Is that sum of difference? Nope. So I don't have any other GCFs that I can take out of 8 and 3, so I know that I factored it completely. That would be your final answer. All right. Don't worry, we're going to slowly step up our game. 8p to the third minus 27. I have a binomial. First thing I should ask myself, is there a GCF that I can take out? Nope.
But it is
Not a difference of squares, but it is a difference of cubes. So the cube root of 8 is what number? 2. I'm left with a p. Bring down your minus. The cube root of 27 is 3. All right, see if you can do the second trinomial. First term of the trinomial will be what?
P squared.
4p squared. Yep, let's make sure you square the 2.
plus 6p plus 9.
Good, plus 6p plus 9. Nice. So your middle term comes from the 2p times the 3. It's always opposite in sign. And your last term comes from the 3 being squared. Okay, and that's just the rule that you need to have memorized. Okay. 100m to the third plus 1. Is there a GCF that we can factor out? Nope. Difference of squares? Nope, there's a plus sign there. So is it a sum of cubes? Yes, it is. Because the cube root of 1 is 1. Oh, no, it's not. Because 100 is not a perfect cube. I was thinking 1,000, right? 100 is a perfect square. So is this factorable? No. So not
Close.
factorable you can write, or our textbook uses the word prime. That's up to you whenever you want to write.
I expected to write that, but I
I will. It is easier to write. Less words, less letters. All right. 25m squared plus 121. Is it a difference of squares? Unfortunately, it's a sum of squares, or maybe not unfortunately. So can I do anything with it? No, I don't have a GCF that I can factor out. Because it's a binomial, 25 and 121 are perfect squares, but it's not a difference of it. So this would be another case of not factorable or prime. Good, good, good. All right, so let's get to some more challenging ones. This one would be pretty easy. How do we factor p squared plus 10p plus 25?
5 times 5
So you do 1 times 25, which is 25. Factors of 25 that add up to 10. 5 and 5. My leading coefficient is 1. So what are my two factors? P plus 5, P plus 5. If you left it like that, I would give you full credit. The book's going to take it to P plus 5 squared, which that would be a case of a perfect square trinomial. So do you need to memorize the rule for perfect square trinomial? No, because if you just factor as usual, you'll get to it.
I think I already did it. I've been doing that on
Yeah.
without realizing it, so.
Right. All right. Let's find some harder ones here. We're pretty good with all those trinomials. Let's try harder numbers. I want to give you this. There you go. So 28z squared plus 6z minus 10. Is there a GCF?
2.
Take out 2. Okay, so if I take out a 2, I'm left with, what, 14z squared plus 3z minus 5.
Better than we had before.
Now what's inside is not a binomial, so I can't use any of my shortcuts. So it's a trinomial, so we're going to factor as usual. So 14 times negative 5 is negative 70. Right? All right, factors of negative 70. So now I'm going to get on my calculator. Just start doing 70 divided by some things. So 70 divided by...
7 and 10.
Oh, yeah, well, I should have gotten that one pretty quick. Thanks, guys, for stating the obvious. 7 and 10, which one is going to be the negative?
7.
The 7. What do we do next? Over 14, I like that idea. Next move.
5 over 7.
Reduce 5 over 7 and negative 1 over 2.
Yeah.
Right? It's a half. So what are my two binomials going to be?
Z goes on the bottom one, right?
Yep, so good. Oops, I missed the 7. 7z plus 5. 2z minus 1. And don't forget about that original 2 that you factored out. Alright, we need to find some hard ones. Ooh, those are nice. Alright, let's try, we only have 4 terms. Here we go. So 20k to the third plus 4k squared minus 45k minus 9. So you've got 4 terms, which means we should factor by grouping. First try right now, can you factor by grouping the first 2 and the last 2 together? Does it work out? All right, so if it does, continue through with it. All right, so did you get to what I have up there? 4k squared minus 9 times 5k plus 1. The order doesn't matter, whichever one you had first. So now, let's ask our question. Here I have a binomial. Is it a difference of squares, sum of cubes, or difference of cubes? This is a difference of squares, isn't it? So this is when I get excited because my factoring isn't ending quite yet. Because we can factor that. What does 4k squared minus 9 factor to? Yeah, 2k minus 3 times 2k plus 3. right? Because the square root of 4k squared is 2k, the square root of 9 is 3. Bring in your plus and your minus. Bring down your 5k plus 1, because is that a difference of squares, sum of cubes, sum of difference of cubes? No. So that comes down into our answer. So that is your final answer. If you stop here, you're not going to get full credit because you did not completely factor it. So that's why you should always ask yourself, the binomials that I'm left with, are they any of these special 3? If they are, then you should continue further. All right, let me give you one more challenge one before I send you out the door. Let's do... There's one that just keeps going. Ooh, that one looks a little rough. Let's try it. Here we go. You ready for this? Erase this. So you're going to factor. Let's do x to the 16th minus 1. Can you factor it? Binomial. Is it any of these special 3? Yeah, it is. Because what did we say about our difference of squares? As long as the exponent is even, it's a perfect square. What's the square root of x to the 16th? Just divide it by 2, right? Well, actually, no, don't divide by 2. You divide it
by 4.
because it would be x. No, it would be because you add, right? So it would be 8 and 8, right? Yeah. X to the 8th plus 1, x to the 8th minus 1.
This one isn't difficult, it's just tedious.
Can that go any further? Is this a difference of squares? So what's that going to go to? X to the 4th plus 1, x to the 4th minus 1. Ooh, I am salivating up here. What else can we do?
X to the 4th minus 1 again.
Goes to what?
X squared plus 1 and x squared minus 1.
Oh boy. Why am I still happy?
Because it goes even further, doesn't it?
Because it goes even further. Which one goes further?
X squared minus 1.
Goes to what?
X minus 1 plus 1 and x minus 1.
Good. And again, it doesn't matter what order you have them in. You just need to make sure you have all of your factors. Can any other ones go further?
No, thank
So
God.
now we're done. Isn't that beautiful? No, you don't think that's beautiful? All right. I'm going to give you a remainder of